Here we see that the frame is coming along very nicely. But before we can continue with it, we need to make the bearing caps. They'll go right there and will become part of the bearings. And the castings have a little bit of a flash or a rough edge down here. So to clean that up, I rubbed the part on a file to make it have a clean surface, which would be the start of where we would rest it on in the milling machine for the first cleanup cut across what would be a top here. So next we'll need to make the bearing caps. First we'll clean up this end of the bearing cap casting where the sprue was. And I just advance about 5/1000ths of an inch at a time to make a pass with the mill. I'm using a 5/8 mill and a collet. This could also be done with a fly cutter. And I think one more cut and we'll call it quits. And there we've cleaned up one end of the bearing cap. Now we'll clean up the other end of the bearing cap casting. And I think just a couple more thousand, so we'll call that side done too. And there we've cleaned up the other end of the bearing cap casting. Now I'm going to clean up the base of the bearing cap casting using a 3/4 inch mill held in a collet. Now you can use a fly cutter if you don't have a mill that big. So here we go with cleaning up the base of the bearing cap casting. And there we've cleaned up the base of the bearing cap. Here I've located where to spot mill and drill the first of the 4 mounting holes in the bearing cap. I'm using a locating pin to do that. Now the positions of the mounting holes aren't critical, but they should be uniformly spaced and fit well on the casting. Here we go with spot milling the first bearing cap mounting hole. And I think we need to go a little bit more to clean up that hole good. And there was spot milled the first bearing cap mounting hole. Here we're spot drilling bearing cap mounting hole number 1. And there we've spot drilled the first mounting hole. Now I'm going to drill the first bearing cap mounting hole through with a number 29 bit. And we're through. And there we've completed the first bearing cap mounting hole. Here I've located where to drill bearing cap mounting hole number 2 using a locating pin. Here we're spot milling mounting hole number 2. And there we've spot milled bearing cap mounting hole number 2. Here we go with spot drilling bearing cap mounting hole number 2. And there we've spot drilled bearing cap mounting hole number 2. Now we're going to drill mounting hole number 2 with the number 29 bit. And we're just about through. There I can see we're cutting the piece of aluminum that I'm resting the part on. So there we've drilled bearing cap mounting hole number 2, locating mounting hole number 3 using the locating pin. Spot milling mounting hole number 3. And there we've spot milled mounting hole number 3. Spot drilling mounting hole number 3. And there we've spot drilled mounting hole number 3. Drilling bearing cap mounting hole number 3. You see we've drilled down into the aluminum that's supporting it, so we're through. And there we've completed bearing cap mounting hole number 3. Locating bearing cap mounting hole number 4. And I just went straight back and I had written down the dial position where this first hole was drilled going in this direction. I just returned to that place again so that they're uniform in this spacing. And because of the way I did it, they're also uniform in this spacing. Spot milling mounting hole number 4. And there were spot milled mounting hole number 4. Spot drilling mounting hole number 4. And there were spot drilled bearing cap mounting hole number 4. And now we're drilling mounting hole number 4. And there we've drilled all the mounting holes in the first bearing cap. I'll make the other bearing cap off camera. I've mounted the frame casting to a small angle plate for the next operations that I'm going to do, which will be to machine this surface back here when it's sitting horizontally, and I'll be able to tip that plate up by loosening the vise and retightening the vise. Now, I had to be sure that this edge here, which is parallel to the center line of the engine, is parallel, a tram, with the long direction of the milling machine table. And I do that using an electric edge finder that lights up when it touches. And there it lit up. And I observe on my milling machine dial at what number on the dial it just touched and came to light up. And then I go to the other end. I do some milling machine table travel. And I do the same thing down there. And it lights up the same number which I actually set as a 0 on the dial. So that means that this surface here, which is parallel to the center line of the engine, we made it that way, is now parallel to the long direction of travel of the milling machine. And because it's a good milling machine, it also means that any cutting that I will do in this direction will be at right angles to the center line through the frame. And in a little while I'll tip that up and make this part here be flat and horizontal, and we'll be able to machine that. I've set up the part to mill the area where the bearing caps will be mated, and I've set the angle simply by pressing that area up against the bottom surface of the milling machine chuck, which is quite true. Now we'll mill the tops of the bearing cap supports. And we want to approach the cut carefully. We don't want to put a lot of pressure on the part that just very well aligned, and we don't want to lose that alignment. So that's a little bit of a cut. I'll do 5 more. And then I'm going to go make the same cut on the other side. And it won't take a lot more. It's almost done now on the first side. And here we go, getting ready to mill the second bearing cap support. And that side looks good, and we'll go make the same cut on the other side and call it done. And there we've completed the milling of the bearing cap supports. And they have nice surfaces on them now, nice finish. We're getting set up here to mount the bearing caps. And the bearing caps are a little wider than they need to be. There's a little excess metal on this side here. And I'm going to mount the bearing cap flush with the frame here with a cast surface. And perhaps I'll spot mill that area later to make a round finished area. But the extra metal will be on the inside, and I'll trim it off even with the bearing support later after the cap has been mounted. I'll mill that off. I'm going to use a homemade pointer, which is just a rod with a pointed tip cut on it, to locate where to drill the first bearing cap mounting hole in the frame. And I'll just engage that pointed tip into the mounting hole in the bearing cap, and I'll use my milling machine dial to move the frame around so I like where it fits. And I say, hey, that's just exactly where I would want it to be. And I'll keep adjusting that while keeping this pointer pressing into that hole. And now I know that if I drill there, that's exactly how the part's going to fit. Spot drilling, bearing cap mounting hole number 1. And there we've spot drilled the first mounting hole. Next I'm going to replace the center drill, which has a 3/16 inch diameter and it's being held in a 3/16 inch milling machine collet, with a number 38 drill for tapping the 540 thread into, and it's being held in a Dremel tool collet that has a 3/16 inch outer diameter that will fit the collet. Now I have an 1/8 inch collet for the milling machine, but the number 38 bit is a little bit smaller than an 1/8 of an inch and won't hold tightly in that collet. So there are Dremel tool collets for all those little differences of sizes down to very fine, and I'm holding the number 38 drill in that collet, and then I'll mount that into the 3/16 inch collet. Now we're set up with the number 38 tap drill to drill the first mounting hole before we thread it with the tap. And I've put a tape flag on the number 38 drill to show me what a safe depth of drilling is, because we don't have a lot of metal we can drill through right here and have to be careful not to go through the front of the bearing cap support or tower. All the others will be no problem, we can drill through on those. So here we go with the tap drill for the number 1 mounting hole. And there we've tap drilled the first mounting hole for the bearing cap. Here I've got a tapping pin, an 1/8 inch pin that's 1 inch long in the collet, acting as an axle for the tap handle, and I've got my 540 tap in place. And I'll put a little thread cutting oil on that, and I'll cut a 540 thread. So we're tapping bearing cap mounting hole number 1. Every now and then you back it up. But I think we're just about bottom in that little starting thread area that we have. And I'll put a bottoming tap on next to finish that thread at the bottom where the taper tap can't really get in very well. Now I'm going to finish the thread with a 540 bottoming tap that has a square end and can reach all the way into this shallow hole and thread it all the way to the bottom. So here we go with the bottoming tap. There's a little bit of thread cutting oil on there. So we'll go into where it already has thread. And then we'll just complete that thread to the bottom of the hole. You got to be careful, but I can feel us cutting there still. That's bottom now. You feel a greater pressure. You'll know when it's bottom. If you go beyond that, you're going to break the tap and ruin your part. Just clean that out with a pipe cleaner. And then we've completed our first bearing cap mounting hole in the frame. I've temporarily mounted the bearing cap using a 540 stud and a conical washer, which keeps the hole in the bearing cap concentric with the stud and lined up the way it should be. And I've used the conical tipped edge finder to locate where to drill bearing cap mounting hole number 2. And the edge finder looks and feels like one piece when the cod is lined up on the center of the hole in the part. And the part's in the place I want it to be, so I know if I drill there, that's the way the part will mount. Spot drilling bearing cap mounting hole number 2 in the frame. And there was spot drilled the second bearing cap mounting hole in the frame. Drilling bearing cap mounting hole number 2 in the frame with the number 38 drill. And there we've tap drilled bearing cap mounting hole number 2 in the frame. Threading bearing cap mounting hole number 2 in the frame with a 540 tap. And after a couple of turns, I turn back about 1/4 of a turn to break the chip. And we're at bottom. There's it. I feel the difference in force. If I go any farther now, I'll break something. So we'll just back off the tap, and we'll follow up with a bottoming tap. Now between the taps, I'll clean out the hole with a pipe cleaner to get the chips and the oil out of there and give the bottoming tap more depth to work. And you just clip off a piece and clean up the pipe cleaner and keep cleaning out that hole. Okay, next will be the bottoming tap. Now I'm going to finish the bottom of the thread with a 540 bottoming tap that has a square end. Now it just finishes the last little bit of thread. The taper on the starting tap prevents you from threading, so it doesn't start cutting to the very bottom, and there we're cutting. And we just cut another 1/16 of an inch of thread by doing that. We'll bottom that tap through. So there we're finished the second bearing cap mounting hole. I'm locating where to drill bearing cap mounting hole number 3 in the frame using a simple locating pin because there isn't enough space to use the conical tipped edge finder. And I'm just seeing that the locating pin goes freely into the hole and that there appears to be an even space all around it, an even circle of space all the way around the locating pin. So that looks like it's a good place to drill mounting hole number 3. Spot drilling bearing cap mounting hole number 3 in the frame. And there we've spot drilled bearing cap mounting hole number 3. Drilling bearing cap mounting hole number 3 in the frame using a number 38 drill. And we're through. That one drills through. Threading bearing cap mounting hole number 3 in the frame using a 540 tap. And we can thread that all the way through because it's not a blind hole that goes through. So we don't need to change later to the bottoming tap. There's no blind hole here. And every once in a while I'll turn the tap backwards to break the chip, but we're going right through there. I don't have to worry about bottoming or anything. Just don't put too much force on it. Just clean that out with a pipe cleaner. Get the oil and the chips off there. Locating where to drill bearing cap mounting hole number 4 in the frame using the locating pin. And I see that it goes in and out freely and that there's an equal amount of space all the way around the pin. So that's a good place to drill bearing cap mounting hole number 4 in the frame. Spot drilling bearing cap mounting hole number 4. And there we've spot drilled mounting hole number 4. Drilling hole number 4 with the number 38 bit. And there we've drilled bearing cap mounting hole number 4 in the frame. Tapping mounting hole number 4 with a 540 tap. I'm going to back it off and oil it up a little more. You can have a lot of oil on there. You can have a lot of oil on the part, but very little between the metal and the tool that's actually cutting, where it's doing the cutting. At the bottom it could be dry. And there we've completed the thread. Oops. And here we have a look with 4 studs in place. Eventually we'll use small screws. And we'll just test the fit. And look, there's no binding there. That's a good fit once more. that conical tip edge finder and the locating pin have done their job. Now I'm going to trim the bearing cap to match the width of the bearing cap's support using a 3/8 inch end mill. Let's stop that and check that again by feel. Okay, let's see how that feels. Oh, I feel maybe a couple more thousandths of an inch. That sure looks good. I'll have to feel to see if it is good. There's a mounting washer being chewed up a little bit, but I don't mind that. And I would go like 1 more thousandth of an inch, maybe just passing the tool back. The engine frame is still bolted to the angle plate like it was before when we were holding the angle plate in the vise to work on the bearing caps. Now I've clamped that angle plate to the milling machine table using step clamps, one at each end. And because I haven't disturbed anything, that means if we drill and ream through here, we should be drilling and reaming for the main crankshaft at right angles to this surface here, which is parallel to the center line of the engine. And I can test that with a dial indicator, and I will do that in a few moments. We have the dial indicator set at 0, and if it stays set at 0, as we move along and the part gets moved and the dial indicator feels a different part of this surface here, which is parallel to the center line of the engine, well, because it's staying at 0, it means there isn't a thousandth of an inch change in the height there, not even 1/1000th, and it means that we have the center line of the engine parallel to the milling machine table, so that when we bore for the crankshaft, we will be boring at right angles to the center line of the engine. Here I've set up to drill the bearings, and I've located where to do that using a small pointer. And we want to drill on the crack between the frame and the bearing cap, and at the center of the round and fat part of the bearing cap. And I've drawn some pencil lines and with a ruler located that place. And I'm using a small pointer here. Here we go with spot drilling the bearings. And there was spot drill the upper bearing cap. Now we're going to drill through what we see as the upper bearing with a 3/16 inch bit. And there we've drilled through what we'll call the upper bearing cap. Now I'm going to spot drill what we'll call the lower bearing for the moment using a 3/16 inch long center drill. And there we've spot drilled the lower bearing. Now we're going to drill through both bearings . and there we're into the wood, and we've drilled through both bearings. And there we have a hole through both bearings. Now we'll enlarge the holes with a 7/32 bit. And then we're through with that bit too. Now I'm going to enlarge the holes further using a 5/16 inch bit. And there we've drilled through the bottom one too. And then now we're going to enlarge both holes to 23/64 of an inch, which is a 1/64 of an inch smaller than the required 3/8 of an inch. And after that's done, we'll use a chucking reamer, an accurate reamer which will make a .375 or 3/8 of an inch hole, taking out that last 1/64 of an inch very accurately. So now we'll drill through with the 23/64 bit. And there we're through the lower bearing, into the wood. There we go. Now I'm going to spot mill the outer side of the upper bearing with a 3/4 inch mill, just to dress it up a little bit. Just a very light spot milling. See if we have a full circle there yet. Almost. We're just about there. Just a little bit more. And I think I'm going to call that it. And there's another look at the spot milled upper bearing. I'm only calling it the upper bearing because it's at the top on the milling machine right now. It's really the right side bearing looking from the front of the engine. But because there is a draft or slant in the frame casting, in order to make it possible to, well, in a hard mold, to come out of the mold, in a sand casting doesn't really matter, but there's a slanted tower here. In order to make that parallel to the center line of the engine, I spot milled it so that either the cam or the flywheel will be able to run against that surface well. I want to spot mill the other side of the frame and the other bearing cap to make it look good. So I've turned the angle plate, to which we've had the frame conveniently mounted for several operations. I've turned that plate over and I'm resting it on two 1-2-3 blocks. Now the 1-2-3 blocks are inexpensive setup blocks that you can use, and they're accurate and not very expensive at all. You use them in your setups. They'll keep things that are true. The whole thing is being clamped to the milling machine table using step clamps, and a step clamp set is usually included with this mill, with this bench mill. But if you had to buy one, they're not too expensive either. So I've used my conical tip edge finder to locate the center of the bearing. And you remember, the conical tip edge finder looks and feels like one piece when everything's lined up, so I know I'm lined up. And a little bit I'll put a small spot mill on there. Here we go with spot milling the other bearing cap and the other side of the frame using a 3/4 inch end mill. Still need more. Haven't quite finished up that other bearing cap yet. And I think I'm going to call that done anyway. The drawings call for us to drill a 1/16 of an inch diameter oil hole in each of the bearing caps. It's not a very critical operation, but you should try to center it well for appearance. We'll spot drill that now. Now we'll drill through the bearing cap with a 1/16 of an inch diameter bit. And there we've drilled the oil hole in the first bearing cap. I'll do the other one the same way. The final process in machining the engine frame is to drill and tap two 540 holes for the mounting of the upper rails. Now, unfortunately, my video equipment malfunctioned during the process, and I'm unable to show you that video, but I can describe the operation to you. In order to locate where to drill mounting hole number 1 for an upper rail in the engine frame, we use the conical tip pointer. Now the conical tip pointer has a geometry such that it automatically centers itself in the hole in the upper rail. Then, with the conical tip pointer holding the part in place, we can use the hand wheels on the milling machine to move the frame around until the part is sitting just where we want it. After we have located where to drill mounting hole number 1 for an upper rail in the frame, we lock the milling machine's gib locks to prevent the frame from moving out of position. Then we replace the conical tip pointer with a center drill and drill a spot in the lower rail. Then we drill it with a number 38 drill and tap it with a 540 tap. Although it is unfortunate that I cannot show you video of the mounting of the upper rails to the engine frame, we can take this time as an opportunity to review the tools and methods used to mount the part. The first tool that we would use to locate where to drill mounting hole number 1 for an upper rail in the engine frame is the conical tip pointer. The conical tip pointer, when mounted in the milling machine chuck, can be engaged into the hole at one end of an upper rail, and that will cause the drill chuck and the part hole to be concentric to each other. After we locate where we want to drill the hole in the frame for an upper rail, we use the gib locks on the milling machine to lock up the movement of the milling machine table in both the cross direction and the long direction, so that the frame will stay where we want it and it will have its hole drilled where we want that hole to be. The conical tip pointer is then replaced in the milling machine drill chuck with a center drill, a number 2 center drill. And it's a short, stiff drill that isn't flexible, and we can be sure the spot that we drill will be in the right place. After we have spot drilled the place where we want mounting hole number 1 to be, we then will drill a tap hole with a number 38 tap drill. And that drill is somewhat flexible, but the spot created by the center drill will hold that tip in the right place and will get that number 38 tap drill drilled in the place where we want it. After we had drilled the first mounting hole with a number 38 bit, we replace the bit with a tapping pin, which is a 1-inch piece of 1/8 inch drill rod, and it acts as an axle for the tap handle and assures that our thread will be cut straight and true. Now this is a starting tap with a tapered point. It works fine if we're going to go through the metal, but if we're not drilling all the way through, we might use a bottoming tap which has a flat end to cut the last 2 or 3 threads. After we have threaded the first upper rail mounting hole using the 540 tap, we can temporarily mount the part using a 540 1/8 inch diameter stud, a conical washer, and a nut. Now the conical washer will cause the screw to be concentrically centered in the mounting hole, right in the center, so it won't touch or bind just where we want it. After we have temporarily mounted an upper rail in mounting hole number 1, we can then use a locating pin in the milling machine chuck, and we can move the table using only the long direction hand wheel until the pin can be lowered into the hole at the other end of an upper rail, mounting hole number 2. And the reason that we only use the long direction hand wheel is we want everything to be parallel to the center line of the engine, and the center line of the engine is set up so that it is parallel to the motion of travel of the milling machine, so that just by going in one direction we will have a line between the two screws that is parallel to the center line of the engine. And everything we will be doing and have been doing is to guarantee that things are either parallel to the center line of the engine or at right angles to the center line of the engine. And using this and our reference surfaces, these things come out confidently and easily. Now when we have enough space, sometimes we can use a conical tipped edge finder to locate where something is, or a conical tipped edge finder with the point ground off a little bit so it can go into a wider hole in a shallower material without bottoming out. But this is very useful in finding the centers of things, to find the centers of holes, and also to locate where to drill something. Now I want to review what I hope you will have learned about mounting bolt-on parts with ease and accuracy. Consider the mounting of the cylinder to the engine frame. Now there are three parts involved actually: the cylinder, the inboard cylinder head, and the frame. And there are 6 bolts. So that means that there are 18 holes which have to line up with each other very well in order to have drop together fits. The number 29 drill cuts a hole that is 5 thousandths bigger all the way around when the 1/8 inch 540 bolt is concentric with the cylindrical mounting hole. Now that means that the mounting hole is within 1/200th of an inch all the way around. These are not sloppy fitting holes. Consider the simple tools that we use to accomplish the mounting of the cylinder to the frame. We have the conical tip pointer, which is just a piece of steel or brass rod that we mount in a handheld electric drill, and while spinning the drill, we hold it at an angle against a belt sander and grind a perfect conical tip. The other tool is a simple piece of steel rod that just about fits the hole, the number 29 hole. And sometimes we have the conical tip edge finder too. I want you to consider the ease with which we did this mounting operation. We didn't deal with a lot of numbers. We didn't need to paint on blue dye and scratch it and then punch it with an eagle eye in just the right place. We didn't need super precision gauges or anything like that. All we had was simple tools, common sense, geometry, and true geometry where everything is either parallel to the center line of the engine or at right angles to the center line of the engine. And it just plain fits every time with confidence. And away we go. Let me put a little bit of load on it. It could actually drive something. I've got a little bit of power there.